Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 31 through 34 of the Algebra 2 Trigonometry Regents exam for January 2015. All right, let's take a look at problem 31. It says, determine to the nearest minute the degree measure of an angle of 5 over 11 pi radians. Now, one thing you want to note is that a degree is very much like an hour. All right. So just as you have 60 minutes in an hour, there are 60 minutes in a degree. All right. So if you want to convert degrees to minutes, you simply multiply by 60, just like how you convert hours to minutes. All right. So keep that in mind. Now, the steps we're going to use for the problem solving process are as follows. First of all, we're going to determine what conversion factor to use to convert our radian measure into degrees expressed in mixed number or decimal form. And then we're going to convert the fractional part of the degree measure into minutes by multiplying by 60. Okay? All right, so let's go ahead and start with the first part. Step 1, we have two options. When you're converting from degrees to radians or radians to degrees, either you multiply by 180 degree over pi or pi over 180 degrees. All right? Pi radians, these are the same thing. So when you divide them uh, with one another, you get 1. All right? So that's why they call conversion factors. So we have 5 over 11 pi. So if we have 5 over 11 pi, which of these two options are we going to use to convert 5 over 11 pi radians into degrees? Now, the easy way to do it is that you want to set it up in such a way that the pi radians cancel out. So since you have pi radians as a numerator, you pick the conversion factor that has pi radians in the denominator. So this is a conversion factor we're going to use, okay? So we're going to multiply by 180 degrees over pi radians. And what happens here is the pi divides out, the radians divides out also, so you're left with degrees, which is what you expected to find. Now when you multiply across, you have 5 times 180, which is 900 over 11 degrees. Okay, so 911 degrees, that's your answer. Now let's go ahead and express this in decimal form, and then we'll write it in degrees and minutes. So we have 900 divided by 11. We have 81.81 repeating. Okay, so here this is approximately 81.8181, and in that pattern just keeps repeating. Now we were asked to express the answer in degree and minutes. Okay, let's go back to the question. To the nearest minute, we have to round it to the nearest minute. So the question now is, how do we express this decimal piece of this degree measure in minutes form? Remember we talked about it earlier that a degree is very much like an hour, okay? So how do we convert this fractional part of a degree to minutes? You simply multiply by 60, okay? So what we're going to do, um, we'll just take the decimal part of the answer we have right here, so 0.818181, that's sufficient. Multiply that by 60. What are we doing here? We're converting from degrees to minutes. Press enter, and we have 49.09 minutes. Okay, so 81.8181 repeating degrees is approximately 81 degrees and 49.09 minutes. But we have to round to the nearest minutes. So since the number after the decimal point is a 0, which is less than 5, we just keep it as 49. Okay, so our final answer will be 81 degrees. Scroll that down a little bit. 81 degrees and 49 minutes. 81 degrees and 49 minutes. So there goes your final answer. All right, let's take a look at number 32. It reads, the probability of Ashley being the catcher in a softball game is 2 over 5. Calculate the exact probability that she will be the catcher in exactly 5 of the next 6 games. Now, one thing you want to note is that if two events are mutually exclusive, basically one is success and the other is failure, the sum of their probabilities is always 1. Okay? So, for example, if you toss a coin, you either get head or tail. Let's say if you desire to get a head, the head is success and tail is failure. So what are the odds you get a head is 1 out of 2, and the odds you get a tail is 1 out of 2. So it's 50-50%, zero point 0.5 plus zero point 0.5, you get 1. Okay? So just remember that probability of success and failure for mutually exclusive event is normally 1. They both add up to 1. All right, so the steps we are going to use for this problem are as follows. We're going to write down the binomial probability formula, also known as the Bernoulli trial formula. Okay, now the question might arise, how do you know when to use this binomial probability formula? In most cases, you'll be given a probability and then you're going to be using that probability to determine how successful a trial can be. Okay, so for example, you're given a multiple choice test with 4 options. The odds of getting it right, of course, is 1 out of 4. And then the question will be what are the odds that you get 7 out of the 10 questions on the test correct? All right, so you have a probability, and then you're given a situation, a trial, where you want to see how successful you can be in accomplishing a piece out of the whole. So in this case right here, we're going to be using the binomial probability formula because it's applicable. And then step 2, after writing down the formula, which we have over here, we're going to determine what each component of the formula are, the variable components. Okay, we don't want to make any mistakes interchanging values because that will give us the wrong answer. So we'll list all of them out first, and then we'll substitute it in the formula and use our calculator to evaluate the results. Okay, all right, now let's go ahead and get started. Step number 1. Let's write down the probability formula. So the probability that we have um, our successes, so probability of our successes is simply going to be, is written as NCR here, but you can also write it in this format, N with our successes equals um, and then we're going to multiply this by the probability of being successful, P, raised to the R power, the number of successes you want, times Q. Q is the probability that the event does not occur, times the number of failures that you have. So if you have n trials in all and you have r successes, how many failures are there going to be? It's going to be total minus successes. Okay, so there goes your probability, binomial probability formula. That's what we're going to be using for this problem. So let's go ahead and list all the components out. It's very easy to confuse variables here, so you have to be really careful. All right, let's start with n. N is the total number of trials in all. Okay, so how many games is Ashley um, playing in all? She's playing 6 games, so n is going to be 6. Next variable is r. R basically represents the number of times she's successful. So we're looking for how many times she'll be the catcher in exactly 5 games. So Number of successes is 5 out of 6. Um, all right, so next thing we need is P. P is a probability that she's a catcher. So what's the probability that Ashley is going to be a catcher? Is 2 out of 5. So the probability that she's a catcher is 2 out of 5. And then what's the probability that she is not a catcher? So you remember that the probability of success plus the probability of failure adds up to 1. So if 2 over 5 represents the probability that she'll be a catcher, the probability that this event will not occur will simply be 1 minus the probability that she'll be a catcher, which is 2 over 5. Okay, so don't forget that Q is P minus R. Q is P 1 minus P, not P minus R. Q is 1 minus P. All right, so you find the LCD there. You can write this as 5 over 5 minus 2 over 5. That gives you 3 over 5. Okay? All right. Looks like we have everything we need. We have N, R, P, Q, and R. Perfect. So the probability that she'll be a catcher in exactly 5 games, 5 successes, is going to be 5, choose, no, total number is 6. So we have 6, choose 5. 6, choose 5 times the probability that she'll be a catcher, which is 2 over 5, raised to the number of times she'll be successful, which is 5, times the probability that she'll not be a catcher, which is 3 over 5, raised to the number of times that she'll not be successful, which is 6 minus 5, which is 1. Okay, 6 minus 5 is n minus r. Okay, so the nice thing about this is that we can simply plug this entire expression into our calculators and compute the result, okay? So I'm going to be using a TI 83 plus calculator for this computation. All right, so what I'm going to do firstly is enter this expression right here. I'll put it in parentheses. So parentheses 6, choose 5. The syntax for entering it in the TI-89 is very similar to this notation here. You enter the number on top first, 6, and then I like to use catalog. There's another way to do it, but I like to go to catalog, and then I press N. So where's N? Right there, N. This function right here is your combination function, okay? So NCR just tells you that the number you enter before this function is the N and the number after is your R, okay? So 6 is N, choose R. R is number of successes, which is 5, okay? And then you close that. Now we've entered this part. Now let's enter these other two parts. 2 divided by 5 raised to the 5th power times 3 divided by 5 raised to the 1st power. Okay, enter, and your answer is 0.036864. All right, so let's just write that down. So probability is going to be 0.036864. All right, so that's that. All right, let's take a look at problem 33. If x is a real number, express 2xi times the quantity I minus 4i squared in simplest a plus bi form. Now, one thing you want to note is that whenever the power of I is greater than 1, um, that term should be simplified. It should be simplified either to I, negative I, 1, or negative 1. Okay, so let me just show you a real short chart for simplification of powers of I. Now when you have I to the 1st power is just I. Leave that alone. I square is negative 1. If you have I to the 3rd, I to the third is just the product of these two, which is negative I. And if you have I to the fourth is I squared squared, which is negative 1 squared, which is 1. All right. The beauty of this whole process is that this cycle repeats itself over and over again. So I to the first power is the same thing as I to the fifth. This is the same thing as I to the sixth. This is the same thing as I to the seventh. And this is the same thing as I to the eighth. So this pattern just repeats in cycles over and over again. All right. But in this problem, all we're just using is going to be I square and I to the third power. Okay, so let's go ahead and carry out our steps. So step one is you're going to distribute. All right, and then step two, we're going to express it in the simplest a plus bi form by reducing any i's that has a power greater than 1. Okay, so we have 2xi times I minus 4i squared. All right, you might want to reduce this, but just hold off on that for now. Let's distribute first and reduce later, okay? So don't keep on reducing over and over again. So we just distribute this 2xi to both terms in the parentheses. So that yields 2xi squared minus 8xi to the third. So the question is, which i's are we going to reduce? The answer is both of them. Why? Because their powers are greater than 1. So don't forget, I squared is negative 1, and I to the third is negative I. So we're going to carry out the substitution here. 2x times negative 1 in place of the I squared minus 8x times, instead of I to the third, we have I squared times I, which is negative I. Okay? So let's simplify that. This becomes negative, oops, wrong color. So we have negative 2x minus times minus is plus 8xi. So there goes your final result. All right, let's take a look at problem number 34, the last one in this installment. It reads, on a test that has a normal distribution of scores, a score of 57 falls 1 standard deviation below the mean, and a score of 81 is 2 standard deviations above the mean. Determine the mean score of this test. Now, one thing you want to note about normal distributions is that the population normally dwindles as you deviate to the left or right of the mean. If you take a look at your curve, your normal curve at the on the reference sheet, you see that behavior manifesting itself. Okay, so that's just something to keep in mind. Now in this problem, the steps we're going to follow are as follows. We are going to first of all declare our variables and use that in this problem to set up a system of equations. After setting up our system of equations, we'll eliminate the variable we do not need, which will enable us to solve for the variable that we desire. Okay? So the two variables that we have in this problem are the standard deviations and the mean. Okay, so let's declare our variables in step one. So let's call mu our mean, and then we can call our standard deviation, let's call it sigma. Okay, so let's call sigma our standard deviation. All right, so now that we have declared our variables, we're going to set up our system of equations. All right. Okay, so first of all, we're told that a score of 57 falls 1 standard deviation below the mean. So we have the mean and then 1 standard deviation below it, so is minus 1 standard deviation is sigma, and that gives us what? The score of 57. Okay, so 1 standard deviation below is negative, right? So you subtract that one standard deviation from the mean, and you get 57. All right, so see if you can set up the second equation. A score of 81 is two standard deviations above the mean. So we have the mean again, but now we're going two standard deviations above. So what are we going to do here? We're going to add two standard deviations to that, and that should yield a score of 81. All right. So what we have here is a system of equations. Looks like a totally different language, but what we're going to do here is we're going to try and solve for the mean. Okay. If we want to solve for the mean, it would be smart for us to eliminate the standard deviation. All right. So let's eliminate the sigmas. How do we do that? Well, we just want to create opposites, all right? So this is positive 2. If this were negative 2, then there'll be opposites, and we can just eliminate by linear combination. So we multiply equation 1 by 2. So that should suffice. If you multiply equation 1 by 2, we will have 2 mu minus 2 sigma equals 114. Okay, and then this one stays the same, mu plus 2 sigma equals 81. And then what we'll simply do is combine both equations, just add it downwards. And then we have 3 mu is equal to 195. And then to get mu, the mean by itself, we'll simply divide both sides by 3. In our final answer, you will have mu is equal to 3 goes into 19 6 times, remainder 1, 15 5 times. Mu, the mean, is equal to 65. So let's just write down what our answer means. The mean is 65. If we were asked to find the standard deviation in the same problem, all we just have to do is look for what sigma is, and that will be our answer. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found this clip beneficial to you, do give us a thumbs up. We appreciate your positive feedback. Do not forget to subscribe to our channel for updates to the remainder of this review series and other great math tutorials. If you need support, have any questions or clarifications about this, or any Algebra 2 trick question on the Regents exam, just place a comment in the comment section below, and we'll be glad to address it as soon as possible. More clips can be found on mathcodeserve.com. Thanks again for watching. Have a wonderful day.